Okay, so the next characteristic that we're going to talk about with these functions, the next characteristics I should say, are maximum, minimums, zeros, and y-intercepts. Now, the function that you see here displayed on your screen is actually a quadratic function, which essentially means that there is an x squared term in the equation. Okay, now we're not going to focus much on equations this early, but we do happen to know that this equation for this particular function does have an x squared term. Now there's other stuff around it. There could be a number in front of the x, there could be plus or a minus after the x. There are different things that do take place in order to shift this off of its parent function. But just for the sake of mentioning it, this is a quadratic function, meaning there is an x squared term. The reason I bring that up is because when you have a quadratic, your maximums and or minimums are going to be absolute, okay? And you'll see with the next example that we have something we call a relative maximum or minimum. But maximum essentially means the very top of the hill. And unfortunately, in the particular graph that we have here, there is no maximum because it doesn't have that shape, okay? This would be a negative quadratic. The one that we have is a positive, it's a smiley face, okay? So the minimum is the very bottom of the valley, that point down there. So in this case, our minimum is this point right here. So let's do a little bit of counting and let's identify what this point is. So I'm just going to put like a little blob on the screen here that I can then move around. Oops, I don't want to do that. Well, let's scratch that for now. Let's just go ahead and let's count together. So in order to find my x value, I have to go to the left 2, so that's negative 2. And then I'm going down 1, 2, 3, 4. So negative 2, negative 4 is that point. Negative 2, comma, negative 4 is the minimum for this function. It's the very bottom point. Now zeros of the function are also considered to be your x-intercepts. But really what these are solutions to the equation of this graph. Now we don't even have the equation of this graph, we're just kind of looking at the graph itself. So we can estimate these zeros. Now I'm going to estimate that these zeros, which are the same thing as my x-intercepts, fall here and here. Okay? Well, what are those values? Well, let's look at the first one. That first one, I'm going to the left. It looks like I'm about halfway between 0 and negative 1. So I'm going to call that negative 1/2. I'm going up and down 0. Okay? So the zeros of your function are where the y values are 0. Now there's another 0. If I start counting, I get negative 1, negative 2, negative 3. It's right in between negative 3 and negative 4. So let's call it negative 3.5. And a y value of 0, up and down 0. So those are the zeros of the function. Those are those blue points that I just drew on there. Okay? And then our y-intercept is when this graph crosses the x-axis. So the x is going to be 0. Okay, remember your y-axis is right here. So it's this point right here, this green point, that is considered my y-intercept. Left and right 0, up to my y-intercept is the point 0, 2. Okay, let's look at one more of these. Now this next equation, the next graph, the next function, comes from an equation that is a cube. So this is going to have an x cubed in it somewhere. Now the equation itself is not y equals x to the third, but it'll be something that has a cube in it. And once again, we're not too worried about the equation right now. We're just worried about the function itself and finding these things. Now, if you have a cube, we can't say that this is an absolute maximum or minimum. We call these relative maximums. Oh, that's acting up on me. And a relative minimum, meaning it's relative to the other parts of the graph, but it's not necessarily the maximum for the whole thing. So remember, maximums are tops of the hills, minimums are bottoms of the valleys. So I have a top of a hill right here, and I have a bottom of a valley down here. The red one's going to be a maximum. If I count, I go to the left 1, 2, 3, 4, so negative 4, and then I go up 1, 2, 3. So this is the point negative 4, 3. That's a relative maximum, negative 4, 3. My minimum, the purple one, is to the right 2, and then down 1, 2, 3, 4, 5, negative 5, because I'm going down. So my relative minimum is 2, negative 5. You can actually have more than one relative maximum or relative minimum. All right? Looks like I'm going to have 3 zeros of the function. I have one here where it crosses the x, one here, and one here. So let's start with the far left one. If I count, I'm going to the left 1, 2, 3, 4, 5, 6. So that's the point negative 6, 0. The next one is negative 2, 0. I'm going to the left 2. And then the last one to the right is 1, 2, 3, 4, 5, 6 that way. So that would be 6, 0. Those are my zeros of the function. And then lastly, I have my y-intercept. That's this right here where I'm crossing the y-axis. My y-intercept always has an x value of 0, and I went down 3, so 0, negative 3. This is, in brief, ways to find maximums, minimums, zeros of the function, and y-intercepts just by looking at the graph of the function.